Hey, back again from sunny West Virginia, can't you tell? Alright, so I think it's time for joke of the day, because it's the best part of the day. I need to look for my missing watch, but I just can't seem to find the time. Okay, but we do have time to talk about factorials. Factorials are a situation where it's a mathematical computation, where we are going to find the product of a succession of numbers that are decreased by 1 with each number. So you know what product means. Product means multiplication. So what happens is I'm going to take a particular number and I'm going to multiply it to a whole bunch of numbers. But what I'm going to do is I'm going to take that number and I'm going to subtract 1 from it to get the next number, subtract 1 from that to get the next number, subtract 1 from that to get the next number, and so on and so forth. So that's what you see right here. So when I see this symbol, and this is an N exclamation point means N factorial. And so factorial, like I said, means I'm going to take that N, whatever that number may be, I'm going to subtract 1 from it, and then I'm going to subtract 1 again, and I'm going to continue to do that, and then I'm going to multiply all those together. So say, for instance, if I see a 7 factorial, what that means is I'm going to take that 7, I'm going to decrease it by 1 to get a 6, decrease that by 1 to get a 5, decrease that by 1 to get a 4, decrease that by 1 to get a 3, decrease that by 1 to get a 2, and decrease that by 1 to get a 1. And I'm going to multiply all of these numbers together. Now, when you multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, you get 5,040. So that is the answer to 7 factorial. Now, if you take a look at the next example, it says that I want to do a 10 minus 5 factorial. What that means is, now you got to remember order of operations, and that PEMDAS says do what's inside the parentheses first. So inside that parentheses, I'm going to take that 10 and I'm going to subtract 5. And when I do, I get 5. Now I'm going to do 5 factorial, which based on this definition right up here says I'm going to take that 5, I'm going to decrease it by 1, decrease that by 1, decrease that by 1, and decrease that by 1. I'm going to multiply all those numbers together. And then 5 times 4 times 3 times 2 times 1 is a 120. So that's how you do that one. If you take a look at the next example, it says that what I'm going to do is an 11 factorial divided by a 9 factorial. So what I have to do is I have to do that 11 factorial up on that numerator, which means 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on that denominator, 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, remember that whenever you have numbers like this, you can cancel out the factors. It's the idea of being able to simplify a fraction. Whenever you simplify a fraction, you cancel out common factors on that numerator and that denominator. So all of these numbers here are common factors with all of these, therefore they will all cancel out. So the 9s will cancel, the 8s will cancel, the 7s, the 6s, the 5s will cancel, the 4s will cancel, 3s, 2s, and 1s will cancel. That makes life pretty easy, because now all I'm left with is just an 11 times a 10, which frankly we can do in our head, because we know that 11 times 10 is just a 110. So that's the answer to that third one. Now when you look at the fourth one, what happens here is similar idea. I've got that 11 factorial in that numerator, which we know means 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But we also know that on that denominator, I do have a 9 factorial and a 2 factorial. Now what I like to do is I like to take my bigger number and use it first, because it knocks a lot of this out. So that 9 factorial will knock out all of these back here, because 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which will cancel all those out. But don't forget, I'm also multiplying by 2 factorial down there. So I'm going to multiply this by 2 times 1. and that's the 2 factorial. But remember, these cancel with these and these. 7s and the 6s cancel, the 5s cancel, the 4s cancel, the 3s cancel, the 2s cancel, and the 1s cancel. That's handy because that leaves me with very little over here. Now, continue with that idea of being able to cancel out common factors. I can look at this and I can say, well, that 2 goes into, because this is a fraction, the bar means division, and that 2 goes into 10 5 times. So 2 cancels with 2 once, 2 cancels with 10 5 times. So what I'm really left with in this denominator is just a 1, which I don't have to show a 1 in the denominator. But in that numerator, I'm left with 11 times 5, and 11 times 5 is simply a 55. Now, in the last one, 0 factorial is a very strange beast, and there's no great way for me to explain to you how 0 factorial works, because if I take 0 and multiply it by something, there's nothing to multiply it by. So the strange but exact definition of 0 factorial is that it is simply, let me get a different color so it doesn't mix up, but 0 factorial is simply a 1, and that is just a standard definition that we have. So hopefully this helps you to understand how factorials work, that that's what this symbol right here means, and whenever you see that symbol, you know that that means take that number, multiply it by a whole bunch of numbers. These other numbers, we're just simply going to decrease by 1 every single time. And then with these kinds of things, you just simply follow order of operations as you know order of operations PEMDAS to be. Factorials are very useful in future applications. They show up a lot when you do permutations and combinations. Permutations and combinations allow you to arrange objects and to see how many different types of arrangements you can get. So have a great day.